Good morning. It is nice to see some people here. Now, I've said to bring today some paint, some paper, a pen, something to wipe your hands with. What I didn't say was also a Lego brick like this one would be super helpful. So if you could possibly grab one of these, great, go get it. If you can't, don't worry, you could still join in. It's not a big problem, but it just could make one of the things we're doing a little more accurate. Have I got some blue tack so I can blue tack that on there? Yes. Okay, let's. So, okay, if you could grab a Lego brick, go for it. Right, whilst I'm just sorting myself out, we've got a question here to think about. We're starting a brand new topic. We're going on to data handling today. Here I've got a pictogram showing you how many t-shirts Mark sells this week. Can you tell me how many t-shirts that Mark actually sells? What do you reckon? Have a little think about that. What's our short Marcel air? I don't know where that voice came from. It's a strange voice, Ruth. I've just realised I've not put a post up for people to say hi on Facebook. If you want to say hi, there is a post there now. And you should be able to say hi. Head to Facebook and you can say hi now. Don't worry if you've not got Facebook. If you can't do that, it's no problem. Right, almost ready. Good morning, Maths Love! It is bright and early on a Friday, hey? How are you doing? So if you were looking for a free maths lesson for home educators run by a very experienced maths teacher and home ed mum, especially looking at Foundation GCSE and Functional Skills 1 and 2, you are absolutely in the right place. We are just starting our new unit on data handling with this lesson on pictograms, bar charts, line graphs. We're going to focus in on the understanding. If you want to do practice at home, which I totally recommend if you are actually sitting a qualification, then head to my website, download the workbook. You can use it in the lesson if you want to. You know, the lesson you can do without the workbook, but it's also got links to loads of practice and things there. And you can grab all that for free. So I started off asking you about this pictogram, about how many t-shirts. There we go. That's the word I was looking for. T-shirts Mark sold in a week. And I showed you a pictogram. So you've got a number, right? You've got an answer, right? No, probably. Well, if it's anything like the people that came to Facebook on Tuesday when I did this lesson before, they were like debating what these circles meant. There was lots of different options of answers. Lots of people saying things like, You can't have half a t-shirt. I'll just better take that Lego thing off there. And they're quite right. Yeah, well, you probably, I mean, which half would you have? Would you have the top half, the bottom half, the front, the back? I mean, it'd probably fall off if you just had the front of a t-shirt, wouldn't it? It wouldn't be much good. So, yeah, probably people wouldn't pay for that. So here, yeah, so people are like, well, if this means one t-shirt, each of these circles means one t-shirt, 3.5 t-shirts doesn't make sense. So then some people said, well, what if it meant 2 t-shirts? So this would mean 1 t-shirt. And lots of debate about it, lots of different options for answers. And essentially what we concluded was that we couldn't totally answer this question. I hadn't given you enough information. That wasn't fair. That wasn't right. You actually need something really, really important. And I wanted to make a big deal of this because I have seen many times when I've been like marking mocks and practice papers and things like that, that this is something people miss all the time. It's really important in exams for marks. It's really important in real life for actually being able to present the information accurately. So this 3-letter word is so important. And it is, we need a key. We need something like this, the key that tells us the information that we need. So this is my key. A blue circle or turquoise circle equals 6 t-shirts. So now you've got that information. Now, can we answer this question? I'm going to give you a second to do that. I'm going to write some bits on Post-it notes to answer it too. And we'll see if we get to the same point. See if we get the same answer as each other. Okay. What do you reckon? So the first one, are you saying, well, this is 6. So we've got 6 and 6 is 12. Another 6 makes 18. And then half a circle would actually be 3, wouldn't it? So do you get 21 for the first one? I get 21 t-shirts sold on Monday. What about Tuesday then? How many t-shirts do you get sold on Tuesday? Do we get 6 and then another 6? So we get 12 t-shirts sold on Tuesday. Is this the way we're going with this? Some people went a different way, and I'll talk about that in a second. Some people on Facebook actually used a different way, which is really cool too. I'll go and continue with this way, and then I'll talk about that in a second. So for the next one, I get 9 because the full circle represents 3. The full circle represents 6. The half circle represents 3. So I added those together to get 9. Then 3 full circles. We go up in my 6 times table. 6, 12, 18 maybe. Did we get that? This one. And then finally my last one. We've got 6, 12 plus the extra 3. So did you get 15 for that one? 15. So then finally, we actually just need to add all those together, don't we, to work out how much, how many t-shirts in total that Mark actually sold this week. Did you get the same numbers as me? I do like people to actually point out if I make mistakes, because yeah, I just do. I sometimes rush or just I'm having a moment, or yeah, just normal to make mistakes, isn't it? So we've got to add those up. We've got 21 plus 12 plus 9 plus 18 plus 15. Add those together. What do we get? So they're going to give me 10. That's going to give me 20, 25. For adding those together. And then we've got 2, 3, 4, 5, 6, 7, 75. I get 75, which is good because that's what I got on Tuesday too. I can't fit my S there. 75 t-shirts in total. Did you get the same? Hopefully we're on the same page with that. What I thought was a really nice way that I saw somebody doing it on Tuesday as well was, instead of working out the individual days, they just added up how many full circles and how many half circles there were. So they counted up the full circles. I'll turn you back around again so you can see this. So instead of doing it my way, they just said, well, let's look at the full circles. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 full circles. 1, 2, 3 half circles. So 11 full circles, 3 half circles, and they used that information to work it out. So 11 full circles, each full circle is worth 6, and they had to times that by 11, which gives us 66. And then there was 3 half circles. How did I draw my half circles like this? 3 half circles, and each of those were worth 3. So 3 times 3, which equals 9, and then just added those together. Probably a little bit quicker that way, eh? In this case, I think that was a little bit quicker, but either way is fine. Gives us the same answer. Gives us exactly the same. So keys are really, really important in pictograms. So I thought it'd be nice if we could have a go at creating our own pictogram. I was trying to, how can I make this super accessible to people? How can I make this so we can do this online? And I thought fingerprints. Now, I am going to talk about the fingerprint way. However, we did a fingerprint way on Facebook on Tuesday. Where's my picture? I've got it here somewhere. Give me a sec. I'm going to show you. And you might notice something about this. You might notice. This is the one I did on Tuesday. Wasn't amazingly accurate. It was really hard to do part fingerprints. So I did wonder if it would be easier with a Lego brick instead. So we could do it either or. So you could either use a fingerprint method, or we can use our Lego brick. Okay, and what we're going to do, we're going to have a go at drawing our own pictogram for some information that I'm going to give you. I'm just going to chuck all that on the floor and hope that I can find it later. That will definitely happen, and I love doing it live. Okay, so let's have a look at the information I've got here. What I'm telling you here then, let's get this lead out of the way. There we go. Okay, I'm telling you, these are my number of people. We could also have written frequency here, which also means the same sort of thing. The amount of objects is frequency, but I could have frequency of people, and this is their shoe size. So these are the different options: 5, 6, 7, 8, or 9. And I want to represent 16 people having a shoe size of 5, 20 people having a shoe size of 6, and so on like that. And this is my all-important key. I'm saying a full fingerprint represents 8 people. However, if you have got a Lego brick, we could say, and I'm going to do this, I've got some purple paint. I'm just going to paint the dots on my Lego brick. And this is a Lego brick where it's got 8 dots on it. Because I think they're the most common, I believe. So that's what I was trying to find. There was one that was really, really common. We could say, I could use that as my key. I could say, right, one of those printed, that also equals 8 people. So if you prefer the Lego brick option, you can do it like that. So, people upside down. E's are really hard to write upside down, I find. Okay, so 8 people. So we're going to try drawing our own pictogram doing that. If you've got a Lego brick, do it with the Lego brick. If not, we can use fingerprints for this. Okay, so we're going to draw our own pictogram. You need a blank piece of paper for this and some paint. So where's my blank piece of paper? Here we go. Seamless. See, I knew I'd be able to find all my stuff. Definitely. 100%. So we're going to, with our pictogram, we need just one axis. So that is the line that often graphs, they've got 2 lines. If you've been here before, you'll have seen different types of axes. I actually have one here. So here we've got temperature and time. So often graphs, you see 2 axes. With a pictogram, we're only going to have one. We're just going to have one axis. I'm going to use a ruler to draw this. So don't worry too much. We're just going to have the axis that goes down here, where we put the information that we're using, which is about shoe size. So we're going to need to put down these different shoe sizes: 5, 6, 7, 8, and 9. But we're going to need space for our pictures on the other side. So quite large: 5, 6, 7, 8, and 9. And we're going to need our pictures on the other side of this axis. Now, if you're doing it using the fingerprint model, well, it actually doesn't matter either way. We're trying to make 16 here. We're trying to make 16 people. We've got our key. Each full one of these fingerprints means 8 people. So if I do it using my fingerprints, I want to do 1 fingerprint for 8 people. So I'm dipping my finger in my paint. I'm going to do 1 fingerprint represents 8 people. And then I need another 8, and then it goes 16 in my 8 times table. So 2 fingerprints means 8 people, which is quite a nice one there. If we were in fact using the Lego blocks, we would just need 2 prints of the Lego block instead. So I'll just do that at the other side. We could just do that with our Lego block, and we could see we're representing 16 people. So 1 print would be 8 people. The next print would be 16 people, which is quite nice. Now, I suggested bringing something to clean your finger off with in between so that you can get rid of some of the paint and make this as accurate as possible. Okay, so now is a good time to clean your finger or your Lego brick, or both if you're doing both like me. And we're going to go on to, I've just realised I needed more space for the Lego bricks, didn't I? I'll stop with the Lego bricks and maybe do that one separately afterwards. That might be helpful. So now, the next line we've got, you might have noticed with the next line, we need to make 20 people. Slight problem here. 20 is not in my 8 times table. So I'll go up as far as I can with my full fingerprints. I'm going to go up as far as I can. And then I'm going to have to think about doing part fingerprints. Okay. So same again. I'm going to have 8, then 16. Then I just need to represent 4 more people. So I'm going to need half a fingerprint, because if 1 full fingerprint represents 8 people, half a fingerprint, so just half of it, is going to represent 4 people. A couple of different ways you could do this. You could either just do half on the side with your finger, or it might be easier just to half paint your finger. It's entirely up to you. I am going for the half painted finger. Half painted finger, because I remembered to bring a paintbrush this time, which I forgot on Tuesday. So just half my finger for the next bit, which is why I shouldn't have put my Lego brick on there, should I? Like, now that looks like a full one. I'm annoyed with myself because that doesn't look very accurate at all, does it? Right, what I'm going to do, I'm actually going to get a new piece of paper. Let's start again and make it look more accurate. Let's make this more accurate. If you've had a mess up like me, we could just cross it out, or we could just start again. That's not a problem, is it? So we're going to do 5, 6, 7, 8, 9. And for 5, we needed 2 full fingerprints. So fingerprint here, fingerprint here. For 6, size 6 shoes, we need 20 people, so we did 2 full fingerprints, and then we need a half fingerprint. I'll just put my finger on the side like, that's a bit better, isn't it? That's a bit more of a half fingerprint. Yeah, are we in agreement? Does that look like a half fingerprint? Right, so now for 7 people, have a little think. How many fingerprints are you going to need? Not for 7 people, size 7 shoes. So we're going on to size 7 shoes. We need to represent 26 people. How many fingerprints will you do? How many fingerprints? So we want to represent 26 people. We've got our key. Can you see the key? Each fingerprint is representing 8 people. How many fingerprints will you need? Okay, so we're going up in our 8 times table again. 26 is not in our 8 times table. So we've got 8, 16. These are my full fingerprints. 24. Now I just need to represent 2 more people. 2 more people. That's going to be a bit more challenging, isn't it? So if half a fingerprint represented 4 people, we're just going to need like a little dot, quarter of a fingerprint. Does that maybe look like? Maybe like quarter of a fingerprint to represent 2 people. So somehow we've got to do a quarter of a fingerprint. I reckon the best way is to get paint on your finger and then just use the tip of your finger like that to do a little dot. Because when you press your finger down, it sort of smudges out a little bit, doesn't it? Did you get the same as I? 3 full ones and then a quarter one? What about for size 8 shoes? We need to represent 32 people. How many fingerprints are you going to need for 32 people. I'm gonna get 32 is quite a nice one. You notice that 32 is in the 8 times table. So we're just going to use full fingerprints for this one. You go 8, 16, 24, 32. Might have to make that last one a little bit bolder so it stands out. There we go. So 4 full fingerprints for that one. And the last one we've got, we want to represent, can we see that one on there? Do I need to move it up? Size 9 shoes. We need to represent 12 people. 12 people with size 9 shoes. So similar to before, 12, it's not in our 8 times table, is it? It's not in our 8 times table. So we're going to have to do 8 with a full one. And then we need 4 more people. So we're back to trying to do half a fingerprint using the side of our finger like that. Perfect. Perfect. Right. But you may notice we're missing something. We absolutely do need a key on this. And the key doesn't mean you have to put every type of fingerprint on there. You don't have to do your half ones and your quarter ones. You just need to say what the full fingerprint is worth. So we do need to add on our key. So we have to put key if it's not there already. And we have to say that our fingerprint is worth 8 people, representing 8 people. If you did manage to go and grab a Lego block and you want to see what that one looks like, I'll quickly show you what the Lego block one would have looked like as well. I do feel like maybe this would be more accurate, but I just didn't know if everyone would have Lego blocks or how we would work it. So we'll quickly do that, shall we? I'm trying to work out how to fold this paper without getting paint everywhere. I'll just get a new piece of paper. That'd probably be better, wouldn't it? So if you were doing it with the Lego blocks, we would have the same axes with the same label. So we would still want this single axis up the side and have this labelled with our shoe sizes. So 5, 6, 7, 8, and 9. And then for each one, we're going to be painting a full Lego block for 8 people. So we want the full thing painted if we're representing 8 people. So when we're representing 16 people, we're going to have to print this twice. So I'm going to do it that way on so I can fit this on. So print this twice for 16 people. Now, if I want to represent 20 people, I will do the same again, print it twice to get 16 people, but then I need an extra 4 people. So we would print it twice. Then we need to represent an extra 4 people. So we would print 1 and then 2. And then we want to just paint half of it. So we just paint this half. Maybe give the other side a little bit of a clean so that we're not printing that side. And we will get the half like that. And you could actually count this one with the dots, which is quite nice. And that's very, very similar to if you were doing on an exam paper. Often they actually split little squares up into smaller squares. So you often get 4 smaller squares. So it's a very similar system to what they would use there. So same as the fingerprints, you would use partial ones. So you would use a half block to represent 4 people and a quarter block to represent 2 people. So you would just colour in 2 of those dots there. Okay, shall we have a look at bar charts? So we're going to do a little game for bar charts. With the game, I'm going to have put a bar chart on the screen, and somewhere on it, I've made a mistake. The bar chart's not perfect. And the idea is you've got to try and spot what the mistake is that I've made. Okay, just pull these off my screen. Let's have a little look. Turn this. Getting things all caught up there. So, bar chart, spot the mistake. For each one, I've definitely made a mistake. So here's a bar chart here. I've got my y-axis with the number of people. 1, 2, 3, 4, 5, 6, 7, 8. I've got my bars. The bars are all the same width as each other. They've got these gaps in between. And then at the bottom, I'm telling you, this bar chart is about pet type. And we've got fish, dog, and cats. Have a little look at this. This was the one that people struggled with most on Tuesday. This was the one people found the hardest. So what is the mistake? Can you spot it? Can you spot it? This one's quite challenging. Lots of people found this one really hard. I think it's subtle, but I put it in on purpose because I've seen this come up on exam questions where they've asked you to name, they often say for two mistakes that they've made, and people find this one really hard to spot. I've done most of this correctly, really, really accurately, but this axis here, it's not labelled right. I've not got an option for 0. I've not got an option for nobody having a pet fish, for nobody having a pet dog, or nobody having a cat. This has to start at 0. So it should have gone 0, 1, 2, 3, and so on like that. We could also have called this frequency instead of number of people, but that's not a problem. I've still been quite accurate there. Next, so yeah, should have started at 0 on this axis. Right, let's have a look at this one. So this time I've started at 0. We've started at 0 on the y-axis. Along the x-axis at the bottom here, I've labelled blue, red, orange, pink, and yellow. That's my discrete data. That's the type of discrete data. We've got equal width bars going along like this, and number of people I think I might have said up there. What is the mistake on this one? What is the mistake that I have made here? Anyone spot it? On the previous one, I gave a hint to it. These gaps here. Do you see these gaps? These are actually important. Without the gaps, technically it becomes a histogram, although it's a little more complicated than that because histograms are continuous data, not discrete data like what we're looking at here. To represent discrete data in a bar chart, we have to have gaps between those bars. Those bars, the gaps should be of equal width as well. They don't have to be the same width as the bar, but just the same width as all the other gaps. So on this one here, I really needed to put gaps between the bars to make it clear that it's a bar chart. So in between each of these, there should have been a gap. Next one, what is the mistake I've made on this one? So I've got number of people, my frequency going up the left-hand side on the y-axis. It's starting at 0. And on the x-axis down here, I've got flower. We've got some names of some flowers, daisy, rose, lily, and then 3 bars representing the frequency. What is the mistake I have made here? Can you spot it? This one, well, it was a little more obvious on Tuesday. We'll see how you feel about this. Can you spot these bars? Well, there's 2 big issues, actually. The bars are different widths. We've got a wide bar here, very narrow bar here, and one in the middle here. That's an absolute no-no. They should be the same width as each other. The gaps are also different widths, and again, that's a problem. These should be the same width as each other. I've just circled everything. All the bars are an issue there. Okay, final one then. Final one. We've got number of people that like these sports that have chosen they got a choice of 2 sports, dodgeball or netball. Number of people I've got labelled on my y-axis. I've got dodgeball and netball labelled on my x-axis there. What is the problem? What is the mistake I have made here? What is the mistake? I had a few different options on this one that people talked about. So some people said on this one that the issue was that I've got 2 bars for dodgeball and 2 bars for netball. And yeah, you're spot on. If there's 2 bars representing the same thing, why not just put them together? You absolutely, if you are just asking a single group of people, you should put them together. However, in this case, I didn't tell you this, so you don't know. I was actually asking 2 distinct groups of people which was their favourite sport. Say one group from London and one group from Manchester. And I didn't tell you that because I didn't give you some really important information, which is a key. I didn't put a key here. I should have labelled these either with what they meant or had a key. This is a type of bar chart called a dual bar chart. I'm not sure why it's called dual, because you can actually show more than 2 sets of people, but we call it dual. And we can have no gap between those 2 because they're both representing dodgeball. We can have no gap between these because they're both representing netball, but we had to have a gap in between them here. The problem was that we've not labelled what group of people that we are talking about or given a key to make that information explicit. Somebody else needs to be able to read our data. We shouldn't have to explain it verbally to them. You should just be able to see it and read it. Okay, the last one of the charts and graphs I want to look at today. So just to be clear, for an exam situation, you will need to be able to plot accurate bar graphs, finish pictograms, as well as read them and understand them and pick out mistakes that we've just gone through. You can find all of those links, like I said, on my website to be able to do all of those things. Line graphs. I want to look at line graphs with you as the last bit of this sort of like graphs and charts section. So these ones tend to be grouped together, taught together, because they're representing similar sort of data. Let's have a look at the line graph here then. So I've got a couple of different examples. So both of these, you might notice they've got something in common. They've both got a y-axis. They've both got an x-axis. So these are both line graphs. We've got very distinct points of data here, and they're being connected with straight lines. This one, it doesn't look like it, but it is the same. It is also distinct points of data being connected with straight lines. It's just there's so many of them that they're really tightly packed together. So it can make some of them look like they're not straight lines. They can look a bit curvy just because of how closely together they are. But yeah, these are used often for showing trends. So you can see here something is increasing, then a very steep increase before a steep decline. Or you can also get types of line graph that we've sort of talked a bit about. Well, no, we looked at when we were looking at conversion. If you did conversion of units with me or conversion of money, you can have these straight line graphs where the gradient is the same the whole way, and you can use them to read off. So when we're plotting line graphs, we need to know where we're going to put the data. We also need to know what sort of scale we can use, because you will need to be able to draw a scale on your y-axis, on the frequency axis, that represents the information accurately. This is really, really important in real life because we can see misleading graphs. I'll let you explore where or why people might use misleading graphs, but you might see them in newspaper reports and things like that. And we need to be aware of that. We need to be able to look at a graph and see if it is trying to mislead us in some way. And these are some of the ways that people do this. We're not going to do that. We're going to be transparent, honest, proper, honest mathematicians, okay? So we're going to have a look. I'm going to give you some data. Oh, I realised the other day, give me one sec actually, I changed the data slightly to make it a bit more user-friendly. And I forgot to change it on that slide. So give me one sec. I'm just going to change that. That says the same thing. Oh, what did I? Yeah, no, I didn't. Should say, I know what it should say. I just want it to be consistent. I know I should be more organized doing this in advance, but I forgot. I'll be honest. I just forgot. Right, there we go. Now I can do it. Okay, so first thing I'm going to ask you then is, which of these axes would you plot the population on? Would you choose A or B? So which of these axes would you plot the plot the population on? So we've got two bits of information. One's going to go on this axis here. One's going to go on this axis here. We've got the year going up every 5 years, and we've got the population in those years, 40 million, 44 million, and so on like that. Which of the axes, A or B, would you put the population on? Where would you put it? So, in all honesty, you could technically choose either, but it's not going to look like a traditional line graph if you put it on B. If you put it on A, it's going to look like the traditional line graphs like I showed you before. So as long as you're clear with your information, technically you could use either, but we tend to put population, frequency, things like that on the y-axis, the one that's labeled A here, the one that goes up and down the vertical axis. So usually we will put population and year along the bottom, so time passing going along the bottom. Now we've got to think about the scale. This is obviously going up in huge amounts, 40 million, 44 million, 50 million, 52 million, 69 million. So I've got three options for your scale. Option A is that we label it with those numbers, 40, 44, 50, 57, 69 million up here. Option B is that we go 40 million, 45 million, 50 million, 55 million, 60 million, excuse me, and keep going. These dots represent that we keep going until we get to 269 or above so that we can include it on there. And option C is that we start at 0 and then we go 10 million, 20 million, 30 million, 40 million, and then ... keep going until we're at or above 69 million. Which one would you choose out of those scale options there? Which one would you choose to make a really accurate, honest graph that was displaying the information transparently? I'll let you have a little think about this, and then I'm going to show you a couple of pictures. Okay, so essentially, we have to rule out A. We can't use A. It's not going up in even amounts. This one's not going to represent the data very well because it goes up in 4 million, then 6 million, then 7, and then 11 million. So we absolutely have to rule out option A. You can't have the population going up in unequal amounts. It does need to be in even amounts for us to be able to see the trends in the data. Now, I'm going to go to C next. So C starts at 0. We saw how important that was with the bar chart. We must be able to represent 0. If we use C, it was going up in even amounts. So it goes 0, 10, 20, 30, and these are all in millions. So we would label it in millions. The problem is with this one, well, maybe not a problem. The thing you have to be aware is that our graph isn't going to start until 40 million, and then it's going to go up from there. So that's not very accurate because I've not drawn straight lines, but it's going to hover quite high up. You're going to have like a blank bit of graph down here. Not a problem, still a very accurate graph. You absolutely can do that. C is a valid option. B technically could be a valid option too, but you need to be really clear with it, and you're not likely to see this on an exam, I'll be honest. B was starting at 40 million. That means we don't have that big gap, but we then need to show that we are compressing our axes, and we do that with like this zigzag line here. And that shows us the honest bit of it, that we have compressed that bit of the graph, that if we were to stretch it out, we would have blank a blank bit of graph there. And this one, again, will go up from there. Okay, so technically we could have B, provided you did squash that bit of the graph and made it really clear on the graph. The only one there without any adjustments that we could use fairly would be C. But B, like I say, if you're really honest about the fact that you're squashing the axes, that is fine. You do need to be able to plot line graphs and do those with a straight line and a ruler. It is worth practicing actually using a ruler to connect them together as well, and making sure that you can line those points up really accurately. That is worth practicing in advance. Another thing you need to be able to do is read off of line graphs. So we're going to have a little look at a conversion line graph here. You might notice this one is slightly different to the other ones. This one has got a consistent gradient. It doesn't change how steep it is. So this line is not changing its rate at any point. The question says, Nazim uses this graph to find out how much money she has paid for the number of hours she works. So I've got this off of a past paper. How long does Nazima work to earn £60? So if you have the workbook, you can actually, I've put the graph in there so you can actually do this question, but hopefully this is clear enough on your screen so you can read this off as well. So if you've not got the workbook or you don't want to print that out, you can absolutely do this off the screen too. So have a little look at that. How could you work out how long does Nazima work to earn £60? So for this, we need to find where on the graph it tells us that Nazima's earned £60, and that's on the pay axis. So we need to go to the pay axis, find 60, and then we're going to draw a horizontal line until we reach the graph, the line that's on the graph already. Then we're going to draw a vertical line coming down to the axis that tells us the numbers of hours that Nazima has worked, and we should be able to read it off there that she's worked 4 hours in order to earn £60. How much does Nazima earn per hour? So using the same graph, how could you go about answering this? How much has Nazima earned per hour? Okay, so there's a couple of different ways to answer this one. If you've done that question before, the one we just did, the £60 she earns in 4 hours, we can absolutely use the information from that. If Nazima was earning £60 over 4 hours, to work out how much she was earning in just 1 hour, we've got to share 60 into 4 equal parts, i.e. we divide by 4, which gives us £15 per hour. You can read it off of the graph, but you might have noticed that it's quite challenging to read the 1 hour mark off of this graph. Some people will get it accurate, but one thing is to be aware with this, because you can get an exact answer in an exam situation, they would expect the exact answer. So if we went to 1 hour here and we read that off and you didn't get exactly 15, you wouldn't get the mark. So it's easier to go to a point like we did for 4 hours, or you might notice 2 hours is quite an easy value to read off, because if we go to 2 hours, we come across and find out that Nazima earned £30, and then we can just half that, because we know half the amount of time, she would have got half the amount of money. So it's just to be aware that when reading these graphs, if you can't read the value off really accurately, it's worth looking at another point of the graph where you could find a really accurate reading and using that to do the calculation. You will be pleased to find out that we are ending today on a quiz. We're doing bingo. I think we did bingo last week. We're doing bingo this week, and people seem to be enjoying the bingo. So I think we're going to do a bit more bingo. If you've got the workbook, you've got the bingo grid in the workbook. If not, all you need to do, because I'm going to hold up the bingo, like the options for you, you just need a 3x3 grid. So it gives you 9 spaces like that. Okay, so 2 lines down, 2 lines across, you end up with 9 spaces, and you just cross them off as you go. And I'll show you where the different answers are, and I'll read out the questions to you. We're aiming for bingo. We want to get a full, either a line going across, a line down, or a diagonal line. Okay, so that's what we're aiming for. Now, I have chucked my bingo answers on the floor, so give me a second. Oh, here we go. Good. Right, I've got them. Here are our different options. So, your options are equal, gaps, straight or straight line, true, axes, key, consistent amounts, curve, and false. Okay, question 1. You're going to fill in the blank. So I'm going to read out a sentence and you're going to fill in the blank. Bars on a bar chart must have width. So that where I left the gap, I'll say something. I'll say something this time. So bars on a bar chart must have something width. Which of these would you replace the word something with? And put a cross there on your bingo grid. Okay, question 2. Pictograms have no axes, true or false? I also got, I'm just going to say this actually on a side note, I got pulled up with my spelling of axes. Axis is 1. Axes, which looks like axes, as in like, that is more than 1. So it's the plural of this. So it's unusual for me to have actually spelt something right, but I have in this case. So I'll say that one again. Question 2. Pictograms have no axes. Is that true or false? True or false? Question 3. You need to interpret a pictogram. So you need a something to interpret a pictogram. Which word would you replace something with? Question 4. Your scale must go up in. So you've got to choose a word from there to finish the sentence. Your scale must go up in. Question 5. The straight lines at the bottom and the left of a bar chart are called the. Choose a word to end that sentence. The straight lines at the bottom and the left of a bar chart are called the. Something. Have you got bingo? Did you get it? I'm hoping you did. I'm hoping at that point you get bingo. I did have another question that I was going to read out, but then I was like, nobody can shout out bingo. So then, I'm hoping. I hope you got bingo there. Okay. Bar charts must have. I've said bars on bar charts must have equal width. Pictograms have no axes. Is that true or false? It's false. Got 1. You need a key to interpret a pictogram. Your scale must go up in consistent amounts. The straight lines at the bottom and left of a bar chart are called axes. And we should have got bingo! going across there like that. Did you get it? I hope you did. I hope you did. That is the end of today's lesson. We will be back next week continuing with data handling, but you are also welcome to come back at 11:30. I'll be here doing my all ages maths lesson where we're exploring Fibonacci using animals with shells, particularly nautiluses. How do you say that plurally? I don't know. These lessons are absolutely free, as are the downloads and links to other resources that I provide, because many of you choose to pay me £5 or £6 a month in order to support these lessons, the time I put into them and the time I spend delivering them and planning them. To those people, I send out a thank you. I'm very excited to be sending out my weather activity pack, which is all about maths and the weather, and it's got like activities, a pull-out activity about cloud spotting, lots of cool facts in there and things to explore. It comes with a really funky sticker that I designed, as well as some recycled sugar paper to do a sun activity and some recycled straws to do a chaos activity with. Chaos is a mathematical term, I promise. I've not just made that up. That's just for supporters. Yeah, so if you want to sign up, you can do that. There's a link on my page and you can just click on that link and go there and become a square or a triangle. Okay, I said I would say hi to some people, so I'm going to do that now. If anyone's managed to say hi on Facebook. If you are not on Facebook, hi to you too, because I like saying hi to everyone. For those people that did, we have got someone. Otis! Hi, Otis! It's nice to have you here. Very good to have you here live too. If you are watching this recording, it's also really lovely that you're here for this too. I do understand the recordings work for lots of people so that you can pause and do it as you're going along too. I'll just double check, make sure I've got everyone. Yeah, I have. Awesome. Thank you so much for joining me, guys. You are more than welcome back at 11:30. Otherwise, I will see you this time next week for more data handling. Bye for now.